Lesson 6.4, Factoring by Grouping. When a polynomial has 4 or more terms, we need to factor it by grouping. This may not be the only way to factor it, but this is one of the simpler ways to factor it. Factoring by grouping involves the following steps. Here's our example problem. We have 8p to the third plus 20p squared plus 12p plus 30. First, we factor out a GCF. Between an 8, a 20, a 12, and a 30, these are all divisible by 2. So I'm going to factor out a 2. And that will leave me with 4p to the third plus 10p squared plus 6p plus 15. Now you'll notice these will all still divide by 2, but this last term will not, so we can only bring out that one 2. Next, we arrange the polynomials so that the terms have with commonalities are grouped together. Now in this case, these terms both have p's and they're both divisible by 2. These terms do not both have p's, but if you look, 6 and 15 are both divisible by 3. So they have commonalities. And then we factor out the GCF of each group. And what we mean by groups is we have 2. These first 2 terms are a group, and these second 2 terms are a group. So we have 2 groups. That's where we get the name factoring by grouping. So what I'll do is I still have my 2 that's hanging out front. 4 and 10 will both divide by 2. And then I have 3 p's and 2 p's, so I can bring 2 p's out. That will leave me with 4 divided by 2 is 2. 3 p's minus 2 p's is 1 p. Here I had 10. 10 divided by 2 is 5. 2 p's minus 2 p's leaves me with no p's. This sign will stay the same. 6 and 15 both divide by 3. So if I divide by 3, I have 2p plus 5. Now, you'll notice that these 2 parts match. I have 2p plus 5 and 2p plus 5. If I have factored correctly, those should match. And my last step is we're going to factor out the GCF again. These matching parentheses are the GCF. So what I do is I keep that 2 out front. This parenthesis becomes 1. And then these 2 terms, here and here, become a second parenthesis. And then the last step is just to make sure that nothing else can get factored. So here's how we factor by grouping. Here are some more example problems. These should be arranged already, but let's just double check. I have n's and n's. They have that in common, and 9 and 12 can both divide by 3. So here's my line for my 2 groups. I have a 3 and a 4, so there's no number in common there, but I have 3 n's and 2 n's, so I can take out 2 n's, and I'm left with 3 and 1 n minus 4. From 9 and 12, I can factor out a 3, and I'm left with 3n minus 4. These match, so they become one parenthesis, and the terms in front become a second parenthesis. Okay, let's try this next example problem. No coefficients, I just have m's, and here the 2's are in common, so I'm going to factor out 2 m's from my first group, and that will leave me with 1m minus, well, there were 2 m's and I took 2 away. When this happens, it's m squared divided by m squared, so that leaves me with a 1. So m minus 1 plus 2 and 2, so I can take out the 2 and I get m minus 1. So I get m squared plus 2 and m minus 1. It doesn't matter what order these parentheses go in. I could have still wrote that m minus 1 in front and the terms out front second. Okay, 35, 5, 56, and 8. They don't have anything all together in common that I can divide by. 35 and 5 will both divide by 5, and they both have x's. And 56 and 8 will both divide by 8. So if I take my 5 out and my x, 35 divided by 5 is 7. I took the x away, so I'm left with a y. 5x divided by 5x is 1. Now, here's where things get interesting. When this is a minus, we're going to go ahead and put a plus, and I'm going to take out an 8. Negative 56 divided by 8 is negative 7. 8 divided by 8 is positive 1. And the reason I did that is because I wanted to show you what happens if you factor and your signs don't match. I changed this to a negative. So I would have 5x times 7y minus 1. If I had factored out a negative 8, that would give me a positive 7y, and 8 divided by negative 8 is negative 1. So be really careful of your signs when there's a minus right here. So I have 5x minus 8 and 7y minus 1. What I would like you to do now is pause the video and try to factor these three by grouping. And then after you're finished, unpause and come back on and you'll be able to check your answers. Okay, I haven't answered this one yet, but I wanted to go over that one together. Now this one, once I got to this point, I saw 3n plus 1, and then I had 3n plus 1 again, and nothing would factor out. When nothing factors out, factor out a 1. So I have 4n plus 1 times 3n plus 1. Our next example, I got 5n squared plus 3 and n minus 2. And then the reason I did not work this one out yet is because I wanted to talk to you about how to work this out when you can't readily identify the numbers they have in common. We're going to go back to our factor. So I'm going to factor 224, which is going to give me 2 times 112, which is going to give me 2 times 56. And as soon as I get here, I say, okay, 56, 56. So I know I can factor out a 56. And then I have an a in common. Well, if I take the 56 out, I have 4 left. So 4z plus c. Now, 84 and 21, if I divide 84 by 4 to see if it'll match this, I get 21. Now, these are both negative, and all of these are positive, so I'm going to factor out a negative 21y, and that will leave me with 4z plus c. So I have 56a minus 21y times 4z plus c. Now this is not factored completely. What I neglected, wait, yes it is, I'm sorry, I lied. No, it's not. What I neglected to notice is that these have 7 in common. So I need to factor that out. Now, if I had noticed the 7 at the beginning, I would have factored that out at first, but because I didn't, I noticed at the end that these had a 7 in common, so I factored it out then. So that's acceptable too, as long as you get that greatest common factor factored out. Okay, here are some more examples, progressively longer. I have a 192, a 72, a 24, and a 9. Now, a trick to know if something will divide by 3 is if you add the numbers and that divides by 3. So 1 plus 9 is 10, plus 2 is 12, divides by 3. 7 plus 2 is 9, divides by 3, 24 and 9. So I can take a 3 out of this. When I take a 3 from my 190, I'm left with a 64 x squared y plus 72 divided by 3, which is 24 x to the third minus 24 divided by 3 is 8rxy, and then 3 divided by 3 is, or sorry, 9 divided by 3 is 3rx squared. And then having done that, I recognized, oh, wait a second, all three of these have x's, so I can even go further and take out the x. So I have 64xy plus 24x squared minus 8ry minus 3rx. So I took one x away from here, one x away from there, that x away, and one of those away. Now I can break this into my groups. 64 and 24 have an 8 in common. And they have an x in common. So I have 8y plus 3x. And then here I have two negatives, so I'm going to factor that negative out because these are positive. And the only thing those have in common is an r. So I have 8y plus 3x. So this gives me 3x times 8y plus 3x times 8x minus r. Okay, looking at our next example, I have a 90, a 36, a 150, and a 60. I have A's, but not through all of them. So I have nothing else that I can pull out of everything. So I'm going to bring out that 3. And I'm left with 30 AU minus 12 AV minus 150 YU plus 20 YV. Okay, from my 30 and my 12, I can pull out a 6, and they have an A in common, and that leaves me with 5U minus 2V, and that's a 50. From my 50 and my 20, they have a 10 and a Y in common, but you'll notice this is negative and this is positive, but I want positive and negative, so I'm going to pull out a negative 10Y, and that will leave me with 5U minus 2V, because negative 50 divided by negative 10 is positive 5, and positive 20 divided by negative 10 is negative 2. These match. So I have 6A minus 10Y and 5U minus 2V. Okay, I have 140, 60, 168, and 72. I know they'll all divide by 2 just from looking at them. So I'm just going to go ahead and start with a 2 and see what happens. Okay. Oh, they're still even. So it looks to me like I could pull out another 2 and make that a 4. So what I've just done is I've gone through and I divided by 2 again. Now it looks as though I don't have anything in common with every term anymore. In my first group, I have a 5, 35, and a 15. Those will both divide by 5, and they have an A in common. That will leave me with 7B minus 3A. And then in 42 and 18, I have a 6 in common. And that will leave me with 7B minus 3A. So I have 4 times 7B minus 3A times 5A plus 6. So I would like you to go ahead and try to pause the video. Try these 3. There's going to be some sort of greatest common factor that you can factor out. Make sure you factored the whole thing out. So if you factor something and then you see that there's still more in common, factor it out. And then factor your groups. So just be sure to check your signs when you end up with a negative or a minus right here. And after you're finished, unpause the video and we'll go over your answers. Okay, these were actually a little more challenging. The first one was not terrible. You factored out a 3 and then a 5a and a negative 1 to change this sign. And that gave you 3 times 5a minus 1 times 7b minus 6. Now with this next example, they had an 8 and an x in common, so I was able to factor that out. But then I got to a point where I had nothing in common, so I had to rearrange these, moving this over here to be with that one and this to be with this one to give them something in common. Remember, that was one of our steps, to arrange for commonalities. Then I could factor out the 2x and I could factor out the y, giving me 2x plus y times c minus d. I had a similar situation here. After I factored out the 5mn, I had to rearrange to move things to be close to each other. And then when I factored, I saw I had 5z minus 4c and then 4c minus 5z. So I had to flip those. So I had to change the signs. So I made this n negative, this 4c negative, and that 5z positive, which would turn this into a 5z minus 4c. And then I was able to finish the factoring.